So before we talk about problem 5, I want to tell you about a new tool that we're going to be using. Okay, so first of all, let's remember something. When I take log base a of a to the x, I'm just left with x. And when I take the natural log of e to the x, I'm just left with x. So the new tool, oh boy, okay. The new tool here that we're going to be using is something I'm going to call logarithmiating. And so logarithmiating just means, I guess, when I'm trying to solve an equation, but a variable is stuck in an exponent somewhere, I can logarithmiate to get it out of the exponent. So logarithmiation is just take the natural log or the log of both sides. So since this is a college algebra class, we're not going to spend any time at all talking about why you can do this. But turns out you can, and it's a new thing we're going to use a lot. It's going to be really helpful and fun and happy, okay? I think this is probably best seen with an example, so let's take a look at problem number 5. Using the common logarithm, common or natural logarithm. Remember, common logarithm is base 10, natural logarithm base e. We want to solve for x in the equation 3 to the x is equal to 6. Okay, so you know how I said something just now about x being stuck in an exponent? This is what I meant. Okay, so the variable's trapped in the exponent. Our goal here is to get it out of the exponent. So I'm going to show you 2 different ways to do this. The first way, using the natural log. So I'm going to take the equation 3 to the x is equal to 6. Okay, first of all, I think probably I should say, off of the top of my head, I don't know what power to raise 3 to give me 6. I know that 3 times 2 is 6, but I don't know what power to raise 3 to give me 6. So that's why we're doing this. We will logarithmiate. So we'll take the natural log of both sides. Okay, so why did this help us? Remember, our logarithm rules say that if I have a power in my natural log, or in any log, the power hops out front. So ln of 3 to the x becomes x times the natural log of 3. So far, we have x times the natural log of 3 is equal to the natural log of 6. And the natural log of 3 and the natural log of 6 are just numbers. I don't know off the top of my head what they are, but that doesn't matter because we can treat them like numbers. So to solve for x, I can divide both sides by the natural log of 3. So I get x is equal to the natural log of 6 divided by the natural log of 3, which is equal to 1.630929. And it looks like it keeps going. So I'm just going to say that's about 1.63. We will round up. Okay, we've solved that equation. I do want to show you how to use the common logarithm as well. So we're going to do the same thing. We're going to take 3 to the x is equal to 6. We're going to logarithmiate. So we get log of 3 to the x is equal to log of 6. Just like before, the exponent's going to hop out front, so I'm left with x times log of 3 equals log of 6. And I can solve for x by dividing both sides by log of 3. Whoop, nope. Log of 6 divided by log of 3. And if you put that in your calculator, you will see we get the same answer. We get 1.63. Yep. Okay, so this is 2 different ways to do the problem, but they really aren't all that different, right? It doesn't actually matter what base of logarithm that I use. I can still solve this equation by logarithmating. But because we're in college algebra, I think what we want to do for these problems is use something that we can easily put into the calculator. So if you stare at your calculator long enough, you might notice that there is a button for the natural log and there's a button for log base 10. So that's why for this problem I wanted you to use the natural or common logarithm, because it's something you can easily put into your calculator. So from another math class, you might remember like the change of base formula, but we're not going to talk about that. I just want you to use the natural log or the common logarithm, and in some cases